Oh, Ethan, who are you? Stop!
Good evening, everyone. All right. I wish everyone had a good dinner and we can start learning some Lego programming together on this call. This is Coach David. I'll be working with all of you for the next hour. I'll make it very interactive. It won't be my monologue talking per se, but I will be asking you to join me by answering some of those discussion questions. So stay alert, stay tuned, and stay awake. All right. Before we start, how is everyone doing for the first two training camps? We talked about building instructions and then some of the basic movements, attachment building, and all that. Can anyone share a little bit of their prior experience for the first two sessions? Does it help? Is it too easy or a little bit difficult to understand? So far, so good? Okay, you forgot about the training camp. No problems. We do have the recording, Jack. So I will share with you the a recording link, and feel free to take another look. And if you have any more questions, feel free to bring to the next session, or every Sunday we'll have an in-person work session. Feel free to bring your question there, and we will have a discussion to help you. All right. I hope that helps. All right, so let me start by sharing my screen. I don't have any deck like other coaches did, but I do have the Spike program or Spike Prime software opened. Okay, let me start by sharing my screen real quick. All right, so let's have a gentle start, right? So we already have an overview of all of this on the left-hand side. Everyone should feel comfortable, right? Navigating all these buttons to get access to the starter program, right? Explain, how we build different parts of the robot, and then download some of the training material. One of which is competition ready, something we'll be spending a little bit more time on today. And then there's also build to understand like how to build different components. Like we have different driving bases and different tools and so on, right? For this year, we're gonna have new mission modules, so this will be updated once the Unearthed theme is released. I think in a week. All right, so stay tuned for that. There's also a section called a My Project. So a good practice is after we develop some code, we want to save it. Does anyone know why you need to save your code? Ethan, why do you need to? Oh, sorry. Can anyone hear me okay?
I can hear you.
Okay. So before that, can anyone hear me?
No.
Oh, okay. Sorry, I just realized I was on mute. All right. Sorry about that. Okay, let's start over. We just wasted 5 minutes. All right. Okay, hi everyone. This is Coach David. Today we'll be going.
Before that, we could hear you. Not until like 10 seconds ago.
Oh, okay. So maybe the audio button is mistakenly clicked, so I couldn't I couldn't tell. All right, thank you for that. So yeah, can anyone answer this question? Why do we need to save a code? So for example, here I saved a project called Training Camp 1, driving around. Why do we need to save a code? Ethan?
Because if we don't save it, then we might like forget it, or like we won't have it like in like saved, so we can't go back to it. And
Exactly.
name it so that you know what it is, and like so you can easily like find it in your saved projects. Or on mute again. You're on mute.
Sorry, Jack, do you have another answer to the question? Why do you need to save your code?
Because it'll just restart and you have to do the code all over again.
Oh, yes, exactly. If you save the work, you don't have to repeat the same process next time you run the program, right? Excellent. And another reason is, do we work as an individual or work as a team? As a team, right? In order to work as a team, we need to be able to share our work with other people. That's why when you save the code, each person can develop some part of the program. And as a whole, we join different parts into a bigger program. And that is how we complete so many different missions for the challenge, right? Great. So we understand, some of these modules on the left-hand side and how we use them. And for the last training sessions, we have gone through driving around. I hope everyone have some hands-on opportunity last weekend, right, to experiment some of these codes, right? So if you don't have time, it didn't have time, that's okay. You just spend more time at home or with your host this Sunday to go through each one of them, right? We want to start with the basics. For example, this driving around will walk you through some of the simple driving actions and how we can code those actions, right, in different blocks of code. So you just need to test it one by one and be able to replicate the process, right? So this is just a quick review of the first training camp. On the second training camp, we talked about how to play with objects, right? Let me just quickly review this so we can relate why we are, doing the session today and how they add up to each other, right? Why do we need to build different attachment? Because in order to complete this year's challenge, driving around is not enough, right? We need to be able to build attachments like crawl to move things around, to poke things, to push things, right? And they require some of the creative ideas how to build attachment, right? And if you haven't got a chance, last weekend, we will spend more time this Sunday to build some of the attachments and try to, complete a simple task. In this case, for example, moving a block back and forth to be able to see if we can effectively leverage, additional material to build something like a grabber to get the job done. All right. Any questions on the first two training camps? Cool. All right. So let me make sure I'm not on mute. I'm good. Now let's move on to the third training camp called reacting to lines. Can anyone tell me why do you need to have such a technique or skill as a robot to be able to follow the lines? Reacting here means you want to follow the line, right? For example, there's a black line here, you want to follow it. Why do we need to follow a line in the competition? Anyone? Okay, maybe I will call on someone to give a try. Ethan, you want to go first?
Yeah, I can go. If you like drive on the lines, it's easier to like, there are like lines on the map, so it's easier to like get from place to place or like mission to mission rather than just coding the whole thing out.
Mm-hmm. Exactly. Because we may have lines on the map, right? If you follow the line, you know where to get there, right? It's easier and it's probably more accurate, right? So let me draw something on the screen. I don't know if you can see it. Do you see a circle, red circle?
Yeah.
Okay. So red circle is the starting point, right? Remember we have a map. Let me show you the map. Yeah, so I really want you to understand why we do things before we do something, right? Oh, sorry. I think in this mode, I cannot. So this is the map for this year, right? As you can see, we have lines here, we have lines there. That is probably not a good example, but somehow, you know, we may have certain rocks, right? Or certain things that we can trace to be able to follow as a line, right? Let's go back to the spike program, okay? So if I draw a starting point here, use my tool again. Okay. Oh, somebody's pretty happy tonight. And then we have a destination here, right? Think about this as our kind of starting line, right? You see a half circle, you always start there. If you get out of the area, it's maybe a penalty or foul, right? Something we don't want to happen. So you start from this area, you want to go to that blue area. What are the different ways to get there? This I want to pick a different person. How about Isabel and Aiden? From the red to the blue, how do you go about getting there?
Moving forward.
Yeah, moving forward. And then how do you know how far you move?
Distance sensor or something.
Exactly. So you take out a ruler or your daddy's measuring tape, right? Hopefully your daddy is pretty handy, has a measuring tape that you can borrow, right? You measure the distance between your starting point. Let's say you start from here, right? Let me use a different color. And then you want to stop here at the destination. And this year, the archaeology theme will require to pick some coals, right? Or to dig a hole or do something, right? But you need to get there first. So you measure the distance from this point to that point. And then after you travel this distance, say 100 centimeter or like 50 inches, right? You stop. This is called point-to-point movement, which is also very effective, right? So when we work on the challenge, we'll be using lots of point-to-point movement. As you can tell on the map, we set up different mission themes, right? Each theme has some task we need to complete. Then each task will be located or situated at a certain point. Then we need to be able to travel from A to B, or the starting point to the end point. Exactly. What is another way to get there? So presumably we don't have any lines yet. What is another way to get there, Jack?
You could use color sensors or just code it
Mm-hmm.
in case the blue thing has a specific color, and you could code it to do it. This thing.
That's a very good idea. Actually, that's one of the correct answers. The color blue is a very critical thing, right? Hopefully you don't have other blues in a nearby location. So when you see blue, you stop, right? Or you can say, when I hit an object, no matter it's blue or green or yellow, I stop, right? You don't want to hit it for sure, because if you hit the wall, it's not a good thing, right? But if you get close enough, right, so that you can operate to get the job done, then that's good enough. So what sensor do you use? Did you learn it from the previous session? What sensor is that? When you get to a certain distance.
Apparently, it's this one that looks like a button for pressure when you bump into things, and the color sensor for if there's a specific color.
Mm-hmm. Exactly. So you can use the pressure sensor. If you gently bump into the wall, you stop. You don't kind of bang yourself against the wall, right? That's a very good idea. And if you see blue, you stop. That's also a good use of the color sensor, right? And another thing is once you hit an object and you reach that object within certain distance, say 5 centimeters, 10 centimeters, then you stop, right? You don't hit that object, but you get close enough. The name of the sensor is what? Distance sensor. All right. So I think you almost got it, but it's not exactly the right word, which is completely fine because you're still learning. So use the distance sensor, go in a straight line, you get there, right? And then you're not hitting anything, you get close enough, you can do your job, you get the job done. Does that make sense? Good? Okay. Thank you for your thumb up, Jack. Yeah, so I really appreciate Jack, Ethan, and Isabel, Aiden to answer the questions, and others feel free to jump in as well, because every time you answer a question, I know you understand. All right, that's very important. Okay, so this is called what technique? If the first one is called point-to-point movement. The second one is called marker-based movement. So basically you put a marker. The marker could be the object itself, or could be a block, right? A red block, blue block. And then you can use pressure sensor, color sensor, distance sensor to identify that marker as you travel, right? And then you stop to do something. Okay, so we're going to talk about 2 ways to travel to a destination. The third way is what we are going to talk about today. All right, so that is the line tracing, or the line following. In this case, if you have a purple line, you can follow it to get there, right? Why a line tracing sometimes is better than the other 2 solutions? Why? Go ahead. Oh, do I have the third hand? Okay, Ethan, maybe Jack, you already answered the last question. Let's give Ethan opportunity. Yeah, go ahead, Ethan.
It might be more efficient. For example, like this line, if you like code it, you might have like some wonky movements.
Uh-huh.
But this is like just straightforward. It's just a line, and then it um the coding takes more time. In this line, you just have to, like, for example, if we like make a line follower right now, we can save time later by just whatever line you make, it can follow. But for each different code, you have to code something different. So it takes more time.
That's right. So, oh, I just click on the sorry chat, so I cannot see the. Okay, yeah. So what Ethan talked about is very important concept. It's called module-based programming. Basically, you build a module or function. Every time you call it, you can reuse that without starting from the beginning, right? I build a line traveling function every time I have a line, right? Something like this, straight line or wiggly line, right? Have any of you go fishing? This is like kind of Nightcrawler line, right? And then you have a spaghetti line, right? Any type of line, it always trace. So in this way, you can adapt to many, many different scenarios and just using one program because it's all line tracing, line following. Is that correct? Yes. And another reason we might need something like a line tracing is, let me ask you, right? If you want to get to blue, but I have a green here, I have another green here, like I have another green maybe here. Like there's no way you can travel a straight distance, straight line to get there. Because it will be blocked by objects on the way, right? In other words, a straight line is not a solution. But there is a line nearby you can trace, right? Let me just use a different color. Maybe, yeah, this. To get there. That is why in some scenarios, line tracing is the only solution. Does that make sense? Okay, good. Great. Now we all understand why we need to do this. Now let's dive into the nitty-gritty, so the details, right? I need to clear my screen. Clear my joints. Okay, good. Now let's take a look at this module. So let's take a look, watch this short video together. This is explaining how to find the right line. And explain why we need to follow.
We can't hear it.
Okay, so this video I watched for the first time as well. All right, so but it gave me some inspiration or some new ideas. Like I don't want to replay it, but let me just stop at the first thing. What does this tell you? It stop at black line. How can you use this for solving your challenge? Jack?
It could be like you can know when to stop, and if you bump into it, then that could mess up some coding maybe.
Yes. So this entire thing.
Also, you need to know when you hit the target so you can get working as fast as you possibly can.
Exactly. Very good answer. Ethan, you have something else to add?
For example, you could like, if there's like something that's somewhat similar to a line, you could use this code so that I can stop in front of like a mission.
Exactly. So why the line detection is also very helpful. In this case, we're not tracing a line, right? We're detecting a line. Why do you think in this particular case, the line detection is so helpful? Presumably, you have some task to finish right around that line, right? Just look at this picture. What made you to think to leverage this line out there to complete the job? Because do you see anything else black?
No.
No. So only the line, right? That is the most important thing you need to take advantage of, right? On the map, you probably will see, oh, there are so many different colors. But in certain area, there's only one green. There's only one blue. There's only one red. You want to leverage that, right? You want to take advantage of that for your code so that you go in a straight line. Whenever you hit black, hit red, because nothing else is red in the area, you stop. And that is normally the where the mission challenge is set up, right? So this type of line tracing is highly related to the color sensoring. So we will be using a lot of color detecting to complete the job. At the same time, you also want to use color sensor to be able to detect certain objects because it is only object of that color and it sticks out, right, from the background. For this training session, you also want to build your color base, a driving base with a color sensor, right? In this case, let me just show you. This is the driving base, right? It's no different from the current base that we have already built. And then this color sensor is just this small thing, right? You can attach to the side. Like this is the driving base without color sensor. That is the black color sensor you attach in its front. And can anyone tell me why the sensed color can go back to the robot? How did we make that happen? Because you plug the sensor back into the port, right? We have 6 ports, A, B, C, D, E, F. Can anyone tell me which port drives the robot? Which port controls the wheels? Okay, let me ask another person. I just want to make sure people are still awake. Just kidding. Audrey, do you have an answer to that?
A and E.
Which port controls the wheels?
A and E.
A and E? Or
Like
or any port?
like just
Did you hear the question? The question is you have 6 ports A, B, C, D, E, F. Which port controls the 2 wheels? I can tell you each wheel is controlled by only one port. This is how you plug it in. All right, you plug it to C, the right wheel will control by C. You plug it into B, the left wheel will be controlled by B. So the answer is, it depends, right? Ethan, is that your answer?
Yeah.
Okay, yeah. Which port controls the color sensor? Natalie, do you have an answer to that? Is Natalie still there? Or Vivian? Is Vivian still there?
No, Vivian is not here.
Oh, Vivian's not here there. Okay, no problem. Okay, so the answer is any port. All right. So as long as you plug into a port, it will be connected, but you need to remember which port you plug in. All right, that's the key. Normally, that's a misconception. You have to use certain port for certain things. That's not the case, right? Cool. All right, so let's take a look at this program together. I want one of you to explain the first block and another person to explain the second block. Can you do that? Okay, so this is a test on your previous learnings, right? Everyone have attended the first 2 sessions and have done the hands-on training. They should be able to explain, on a high level, right, how this code is doing. All right. Before we do that, let's think about what are the steps you need to take in order to detect a black line. Just use English, plain English language. Step 1, step 2, step 3. Anyone? Okay, Ethan, you want to give a try?
Like how to detect a black line?
Yeah.
Yeah.
Explain in English. Step 1, 2, 3. Maybe
Step
just
1
step 2 steps. That's fine.
basically you start moving forward,
Mm-hmm.
and then you wait until like the color sensor sees the color black,
Mm-hmm.
and then you can just when it sees the color black, you keep moving forward, and like you basically keep following the black.
Okay, so we're talking about drive and stop. All right.
Oh, so then when it sees the color black, then it just stops.
Right. How many steps in your solution? How many steps do you take in your solution?
2.
2. What are the 2 steps?
Basically, just move forward
Mhm.
until seeing black and then stop.
Okay, 3 steps. Move forward, detect a black, stop, right?
Yeah.
Okay. Anyone else?
Not me.
Jack?
Step 1, you move forward, kind of what Ethan said. Step 2, detect black line. Step 3, if there is black line, stop.
Love it. So both of you said, start moving, detect the black line, stop. 3 steps, right? So that's exactly right. Congratulations. All right. But the catch is, if you do not head into the right direction, can you see the black line?
No.
So how do you find that out?
Oh, wait. It said if it sees the black line, then you stop. But if there isn't a black line, then you don't stop.
But how do you know if there isn't a black line?
Color sensor, I believe.
Okay, but if it never sees the black, it will probably keep going.
Yeah.
Okay. So one idea, I don't want to give you a solution, I want you to think about a solution, is you have an idea how long it takes maximum to get to the black line, right? You set a timer or a certain distance. If you travel beyond that distance or that time, then you know you're heading to the wrong direction, right? This is the way you know you're not able to get a black line and you need to restart or turn around, right? So these are just some of the ideas to help you think about some of the edge cases, because what is the edge case is a scenario that will not happen very often, but if you repeat it many, many times, it will happen, right? So that is called the edge case. It's just like the edge of a table, the edge of something, right? It's a very small area, but it may happen after many repetitions. All right. So both Jack and Ethan said exactly right. 3 steps to detect a line and stop. Start, detect the black, stop, right? So the way we code it out is in the first block. Can we have a volunteer to explain these 6 lines of code that help us to implement this drive and stop at a line in word block? Okay, maybe Jack, you want to go first?
And I'll let Ethan go if he wants.
Okay, Ethan, you want to go first?
Okay. The first code is basically like on the hub, there's 2 buttons, left and right. The first code starts when the left button is pressed, and when the left button is pressed, then it'll set movement motors to C and D and set the movement speed to 50%. And then it'll start moving forward. It'll wait until the color sensor, which is plugged into the B port, is like sensing the color black, and then it'll stop moving.
Love it. So anyone but Ethan, who can explain how these 3 or 6 lines of code can be translated into the 3 steps Ethan and Jack first laid out? Remember the 3 steps: start moving, detect the line, stop moving. Jack, you want to give a go?
When the left button is pressed, you make the robot power up and it starts moving. This, the first 4 lines of code basically means you start moving.
Exactly.
The 5th line of code means that if you see the color black, then 6th line of code, stop moving.
Exactly. The first 4 lines, as Jack said, is the moving step, right? The wait until the color detection is the step, the single line of code to detect the black. The last line is the 3rd step, stop moving, right? Does anyone have a sense of how we develop a code? Who can generalize what we just talked about in the past 5-10 minutes? What are the steps to develop a code to solve a real-world problem? In this case, the real-world problem is you drive a car, you want to stop at a black line. How did we go about implement this program, which is a word block code, to solve this problem? This is not just about coding. This is the problem solving. This is the critical thinking. Yeah, Jackie, you want to give a try?
I'll give it a try. It might not be correct, but I'll give it a try. So it's, you see what you need to do, you know what you need to do, you analyze it, and then you figure out how to do it. So this is so this can be applied to real world problems. I don't know, by if a car is moving, you stop at a certain place if it detects something. So the code can say whatever it says. If I get off topic, well, yeah.
Very good try. Anyone else? Ethan?
Aiden.
You need to know like what your goal is, and then know what all the codes do, and then start like choosing what to code.
Being resourceful.
Yeah.
Anybody hear me?
Yes.
So
There was a lot of silence.
yeah, I think our instructor disappears.
I'll go check on him.
Why is it so laggy?
What happened?
Either lost connection, I think, but I can see the shared screen.
I'm sorry. Can anyone hear me? Okay.
Yes.
Yes.
Okay. Sorry. For some reason, my audio button is always like automatically mute myself. Maybe I touched something. I don't know. Yeah. Thank you. All right. Sorry about that. I just talked about the pseudocode. I hope you heard that part. Did you heard that part?
No.
Oh no.
No.
Okay. Okay. So I will just backtrack a little bit. Aaron, can you be quiet a little bit? Sorry, I have a little one around me. I have to take care of as well. So 3 steps of formulating and solving a problem using code. Step 1, as Aidan mentioned, define the problem, define the goal. In this case, the problem is drive and stop at a line, right? Then you define the goal, right? That is the mission you want to complete. Once you define the problem, define the goal, you come up with an English language explanation. How do you solve this problem step by step? That English language explanation can be understood by anyone. Your grandpa, grandma, people waiting at the bus stop, kids going to Spain for their soccer camp, anyone, right? They don't need to have any idea how to code in Python or Spike program. If you have a step-by-step approach laid out in plain English, you solved 80% of the problem. All right. So I want everyone to think about this. How can you describe how you solve the problem in English, step by step? 1, 2, 3, ABC, bullet points. All right. So we'll have 24 different missions. Each one of them will have a formula. We solve this in 5 steps. We solve that in 6 steps. We solve another one in 10 steps, and so on in English. Once you have that, that is called pseudocode. All right, the step-by-step process of solving a problem in English is called pseudocode. Then you take that pseudocode, work with a coder or developer on our team to code it out. Step 1 will be translated into the first 3 lines of code. Step 2, another 4, 5 lines of code. Step 3, and so on. Does anyone get the idea? Okay, cool. So for the sake of time, we'll move on to the second part, and we'll have another volunteer to work us through the second block of the code. And I will talk about a slightly improved version of the code, right? And to give you some sense of, there's no single way of doing things, right? For anything you do in your life, at school, there's always multiple ways to do it. And we need to talk about strategy at your age. What is strategy to you? Strategy is to make choices. Right? You have so many different ways of solving a problem, but which one do you pick? That is a very hard problem to solve. All right. So let's move on to this: driving on a line. All right. So who can tell me how do you solve this problem in plain English? Step 1, 2, 3. 1, 2, 3, 4. Give yourself a few seconds. All right. Okay, let me blow this up and give you some idea. Let's say, let's assume, all right, you start on the right-hand side of the black line, which is where the robot is currently located, right? This is left, that is right. If you start on the right-hand side of this line, what is the first step? Can anyone still hear me okay?
Yeah, we can hear you.
Okay, thank you. Oh, I just realized something, but I will talk about it later. I don't want to spend the time. Okay, Jack, go ahead. What is step 1?
Step 1 was like define your goal or define the things that you want to do.
Yeah, so that one is already checked. We know the thing we want to do is to follow the line and go forward. Reach the end of the line. Yeah, that one is done. Good job. What is the next step? Oh, let me give a hint. All right, you always start with some starting position, right? You want to make sure you are facing the destination. Step 1 is point your robot to the line. Is that correct?
Yeah, I'm pretty sure.
Yep.
Yeah, if you point the opposite, then you will not be able to detect the line. You will not be follow the line either, right? Pointing your robot to the line, right? In this case, you want to point the robot this direction, right? Okay. What is step 2? Shall you, will you start moving? Do you need to move? Yes. So step 2 is to move straight line, right? Just move forward. What is step 3?
How to do it.
How to do it. That's a little bit too broad, too general. Just like we detect the line, right? Do you need to detect the line?
Yes.
Yes. Okay. So you start moving, step 2. Step 3 is to detect the line, black line. What is step 4?
Step 4 is the coding.
We are still going through this.
Oh man, I
pseudo
completely
coding.
forgot about that.
Yeah. No worries. This is how we learn, right? We try to refine our learning as we go. So detect the line. If you keep moving or you stop, either way, it's not gonna work, right? Because you are supposed to trace the line, you cannot stop. You are supposed to trace the line, you are not supposed to cross the line and keep going. Is that correct? Yes.
Mhm.
Okay. So after you hit the line, be quiet, please. After you hit the line, what are you gonna do? You want to figure out, are you about to go over the line, right? So Jack, you have something to share?
Probably like, are you going to follow the line or something?
Yeah, you're gonna follow the line. So we're talking about how we can follow the line, right? So in this case, if you just touch the line a little bit versus you are right on top of the line, does it make a difference? Does it give you different information?
Yeah.
Yeah, right?
Maybe.
Yeah,
Like if you're touching the line a little bit, maybe like the line's turning or something.
right. So you see something different, right? Have you ever have any of you gone fishing before? If a fish on a bank versus a fish in a boat, it's different, right? Fishing on a bank, you only see, the water in front of you. Fishing on a boat, you see water all around you, right? You see something different. Same for the robot. When I touch a little line a little bit, I see a little bit of black, right? Remember the color sensor is just like our eyes or a camera, right? But if you right on top of the line has some thickness. It sees lots of black. Maybe right in the middle, it sees all the black, right? So this percentage of black or how black your sensor is detecting is very useful information. So you want to leverage that to say, okay, if I touch the line, right, I can keep going a little bit, but at some point, I need to make a turn, right? So that is the kind of the percentage of blackness you can use to tweak when you're gonna turn. But anyhow, the next step is to make a turn. You just need to figure out what triggers that turn, right? You can see when I detect the black, I turn, or when I sees some percentage of black, right? I turn. So after you turn, you want to make sure you follow along this line to go back and forth, right? Because if you go to the left versus to the right, you will see the percentage change in the blackness, or the color you detect will change, right? So that is how we implement the simple solution for this line tracer, all right? So let's just take a look at this code. This is a relatively simple solution. I would like to have one volunteer to work us through this code, and then think about the step-by-step process we just described in English, how it got translated into this code. Any volunteer?
Hi.
Yeah, Aiden?
Well, when the right button is pressed, the motor CND will move forward at the speed of 30%. And then when the color center sends it black, move right 50 degrees. And if it is not sensing black, it would be moving left -50 degrees.
Very good. Yeah. So does this one, what is the kind of the detecting block or detecting logic here? Is it proportional of the color, or is it like a binary? Yes or no type of decision? It's binary, right? Binary means yes or no. Is it the black? Yes or no. Is it white? Yes or no. In this case, they use a binary decision. That is, did I detect a black? If yes, you are on the line, or you touch a little bit of the line. As long as you have some sense of black, you detect a line, right? If you detect a line, you keep going to the right, 50, which is an angle. You're still moving forward, right? This entire forever block is to move forward, but this right means you kind of leaning a little bit towards the right by maybe 50 degrees, something like that, right? And then if you keep moving, it will be move across the black and into the white. That's why you want to move in the opposite direction, right? The -50 to bring you back to the line. Okay, so I think this right and left may also mean the wheels, right? The right wheel, drive you forward 50 degrees, the left wheel drive you backward 50 degrees, something like that. Does this make sense at all?
Mm-hmm.
Good.
Yes.
Okay.
Yeah.
All right. So what's the problem with this binary decision? It says, if I detect a black, then do something. If it's not black, which is white, I do something else. What is the problem, potential problem? How about this line is very thin?
It could miss the
Maybe-
text, like
Yeah.
would go past the line.
Yeah, how about this line has been exposed in the sun for a little bit, so it's not true black. It's kind of gray, right? So this color detection based on true black may not work, all right? So that's why we want to think about how we improve the code. Let me just give you some ideas. I'm not gonna give you the solution, but just gonna spark the thinking, right? This is a deck I found from like a robot training website. Everyone have access. I will be sharing this with you. But I really like the kind of the graphics they have included here, right? So this is one idea that is not detecting black or white, but detecting the the percentage of black and white. All right. So as you can see here, it makes a difference where you start, right? And then here is the only difference of the code. Actually, it's a very easy change for using the percentage instead of the black and white, right? The only keyword we need to use here is reflection, right? So if it's a completed white, it's not gonna have if it's completely white, reflection is 100%, right? Because the white is reflecting everything, right? For example, if you wear a white shirt, you shoot a red light, it will turn red. It is because it is reflecting red. If you shoot it with a blue beam, it will turn blue, right? Things like that. So reflection 100% means it's white. So if the reflection is less than 50%, you know it's more black than white, right? So how does that translate into this? Right? So if you are half on the edge of the line, half black and half white, it's probably 50%, right? But if you go over a little bit more, it will be more black than white, then you know you should go back, right? So this is more flexible algorithm because it does not heavily rely on either black or white or some other color, and you can easily just change this reflection number to adapt to the specific situation you are dealing with, right? So this is a much better way to improve your code. Instead of just coding the binary, you can use the proportional of the color, right? In terms of the reflection. And another tip I want to share is within this code, right? You are using this simple movement like driving to the right, driving to the left by a certain degree. Remember, you have two wheels, right? So the problem with this code is it's gonna give you a bigger turn, right? Because you know you are only controlling like one parameter, which is going right by 30 degrees, things like that. If you have two wheels, you can actually set the speed, set different speed for different wheels, right? If you want to, for example, turn right, you can set a slower speed to your right wheel and a higher speed to your left wheel. So your left wheel actually goes faster, and at the same time, both wheels will still move forward, right? Things like that. You can think about how to fine-tune your process to make it work better. All right. Does anyone have any questions based on what we just discussed? Cool. So homework, all right? Yeah, so this is exactly what I just talked about. It's just the next slide, using the percentage value. In between now and the weekend, try to find some time for yourself to go through this code. Everyone have downloaded software. You can easily launch it to access the training camp. In this case, it's module 3, right? Reacting to lines. Just launch it and go through the code as what we just, how we just did it, right? And then Sunday, we will have another work session with everyone. Please join that session to test it out. Again, the goal is not to spell out each word in the code one by one. The goal is really to be able to understand this code, the sample code, and be able to run it to see how the robot reacts to it, and change some of this parameter to make sure you understand how it controls the robot and be able to move more smoothly for the robot to trace the line. All right, so that is the goal of the Sunday in-person session. With that, I will just leave 1 minute for any additional questions before we break. All right, excellent. Yeah, Jack, go ahead.
I forgot how we get to the training camp. Wasn't it by Google
Yeah.
Drive?
No, actually, you Google it, you search Spike program software in Google, and you should be able to download it.
Got it.
Yeah, cool. Very good question. So just a spoiler for Thursday, we're gonna talk about the remaining modules, starting with the advanced driving base. Then we'll follow up with the best practice and some of the other stuff. So please join the session. And as usual, we will be, doing lots of interaction like what we did today. And hopefully more of you can join the conversation. But thanks for everyone for your participation, and have a great rest of your evening.
Bye.